destructors in C++, right? So when you write a program using constructors, then definitely you have to use destructors in that program. Okay, definitely we have to use destructors in the program, right? Like constructor, what is a constructor? It's a special function. Okay, which is used to assign values to the private data members of the class. And what is the name here? How do you what is the name of the function of the constructor? Class name is the constructor name. Class name is the constructor name. Okay, destructor is used to erase. It is used to erase all the memory allocated for the object using constructor. See, for the class student, for the student class, you are creating object S1 with name and some age, right? What is happening? A parameterized constructor is being executed. Okay, it is executing. It is that is using some memory space. It is using some memory space. Why? Because this ABC and this 30 has to be stored and they have to be copied. Okay, so this S1 object is occupying some memory in your RAM, in your memory space, right? It is occupying some memory, this object S1. Now, once the job is over with this S1, we have to use destructor to erase the memory allocated for this S1, to erase the memory allocated for this object S1, we use destructor. The best way to understand this is using malloc function, malloc or calloc function. In dynamic memory allocation technique, we use malloc, calloc functions to allocate memory. But to delete memory, what we do? We use a function free. I hope you are aware of this. Malloc and calloc function are dynamically are some functions which help us to allocate memory dynamically, right? Then there is a function free. What it will do? Whatever memory you have allocated using these functions, that will be deleted using this free. Even in linked list we are writing no free of temp, the temporary pointer we are deleting it, right? Why? The use of temporary is over now, I want to delete that. Like in dynamic memory allocation, we are using memory allocation techniques and then deleting it. Same way, when you use a constructor, whatever memory was allocated for this constructor, for this maybe or for this object S1, using this constructor has to be deleted, and that will be deleted using the destructors. Okay, so the purpose of destructor is just to delete the memory allocation which has taken by this object S1 using the help of constructors. Okay, so let's understand the definitions and the syntaxes of this destructor class. Right, see, destructor is an instance member function. It's an instance member function that is invoked automatically whenever an object is going to be destroyed. Whenever an object is going to be destroyed. Okay, meaning a destructor is the last function that is going to be called before an object is destroyed. How will I know an object is being destroyed? How will we know that? We don't know. But when you write a program, when you create an object, when you call a default constructor or a parameterized constructor, then you definitely have to include destructor. Okay, what will happen once the program steps are executed? Then before coming out of the program, the compiler will run this destructor automatically, which will delete all the memory allocated for those objects using constructors, which we are using constructor concept, that memory will be deleted, right? Practically you will not see the difference. See, when we write free of the temp, okay, using malloc, when you are allocating memory, you are able to see that. We are able to see this. Why? Because it is allocating some memory, reserving some memory, and I am putting some 10 into the variable A. Using malloc, dynamically I can allocate a memory like this. When I am printing it, it is giving me value 10. But when I write this free, it is deleting this complete block. How do we do that? We don't know it. But as a sign, that that memory should be released, we are using free. Since you are creating it dynamically, we are erasing it manually by using free function. Same way, when you are creating an object S1 with some values, okay, a default constructor is being executed. That constructor is occupying some memory. Means again the object S1 is occupying some memory. Whatever memory was allocated for this object S1 has to be erased before you come out of the program. For that, we use the destructors. Again, the syntax, see here you have to use, for constructor what you are doing, for constructor you are writing student, and you are writing the variable names like this, int x comma int y, and you are writing some set of statements like this. This is the class name and you are passing the variables. So this is a parameterized constructor. Whereas to write destructor, you have to use this tilde symbol. You have to use this tilde operator. Tilde operator, same class name student, and you can write some set of instructions. Okay, tilde operator, student, open and close, flower brackets, open and close. You can write some set of instructions here. Okay, so when you don't have a tilde operator in front of the class name, it's a constructor. If you write a tilde operator in front of the constructor name, that becomes a destructor. Okay, so that is the notation here, right? So if you want to define, again, like constructor, the body of the constructor can be inside the class and also outside the class. Same way, the body of the destructor can be inside the class or can be outside the class. But when you want to define something outside the class, what you have to do? You have to use class name, scope resolution operator, then the destructor name, that is again class name, like this. Okay, so like constructor, you can define it inside the class or you can define it outside the class also. Both are allowed. This is same as the way we are doing it in constructors also, right? Let's see some important characteristics of destructors. Destructor has much more characteristics when compared to the constructor. Let's try to understand this destructor. See, destructor has the same name as the class name, but preceded with a tilde symbol, this operator. It is not possible to define more than one destructor. See, constructor, you can define a default constructor, a parameterized constructor, and also you can define a copy constructor. Okay, you can define a copy constructor, but destructor should be only one. Destructor should be only one. You cannot have multiple destructors in a single program, right? You cannot define more than one destructor like we are defining more than one constructor. Okay, the destructor is only way to destroy the object created by the constructor. Whichever object you created using the help of constructor, destructor is the only way to delete that particular object. Hence, destructor cannot be overloaded. We cannot do overloading. Why? Constructor we are doing overloading, no? You are having a constructor student without any values. You are having the constructor student with a default argument like this, or you are having a parameterized constructor like this, int x comma int y. This is what again overloading of functions, right? But destructors cannot be overloaded. Okay, it cannot be declared as static or constant. It cannot be declared as, same constructor also cannot be declared as static or constant. Same like constructor, destructor does not requires any arguments, okay, nor returns any value. Destructor will not take any argument, it will not return any value. But in constructor we can take arguments. Default means no arguments, parameterized means some arguments. Whereas destructor will not take any argument, it will not return any value, right? It is automatically called when the object goes out of scope. It automatically calls when the object goes out of scope, right? It is same as your free function in the dynamic memory allocation to delete the memory allocated for that object. Okay, destructor releases the memory space occupied by the objects created by the constructor. Whatever memory was allocated for an object of a class using constructors, that memory can be erased using destructors. Okay, The next point, in destructor, objects are destroyed in the reverse of an object creation. Okay, if object obj1 was created first, then obj2 was created, then obj3 was created. When you write a destructor function with class name like this, empty, nothing in that. When you write a destructor function, first object 3 will be deleted, then object 2, and then object 1. Okay, this is how the objects are deleted, right? See, the important point here is that if the object is created using new, or the constructor uses new to allocate memory, then we have to use only free function. If new keyword was used to allocate memory, then definitely you have to use free. Default constructor will not work. Why? When you use new, you have to use free. If you are using constructor, then use destructor. That is the point here. So these are few set of characteristics of destructor or some important points about the destructors. Okay. Next, let's say a simple and a dummy example of a destructor. See, I have a class test. I have a class test. For that test, I am creating an object T. For that test class, I am creating an object T. When you create an object T, immediately the default constructor will be executed. What is the default constructor? It is test. See, this is a default constructor because it has no arguments. This will be executed. So what will come as output? Constructor executed will come as the output. After that, you have written 0. Nothing. Once this is created, you have written 0. So while closing the program, while the compiler comes out of the program, it will execute this default, this destructor. See the destructor syntax here, how we wrote it? We wrote negation of test, empty brackets. And in this I wrote destructor executed. This is just a proof that this will be also be executed. Okay, you can only see it happening with this printout, with this cout statement. Otherwise, you cannot feel that destructor is working, because we cannot open our RAM memory and check whether the memory is released or not. That is not possible. It is very difficult to identify what was the memory allocated for that variable and is it really erased or not. It is difficult, right? So this is just a dummy example to demonstrate the destructor concept. Using a default constructor, I am allocating memory to this object. Anyhow, there are no variables, so this output will come. But while coming out, when you execute this program, you will see two statements: constructor executed, destructor executed. Okay, but if there are so many other lines in between, see, after writing test T, okay, this you will see this output, constructor executed in the output screen. Then let there be so many statements. Then you have written 0. In this case, constructor executed will come. This all statements will execute and some of the output will come here. Then the message will come destructor executed. So always destructor is the last function to be executed in the program. Whatever functions you gave here, whatever operations you wrote here, whatever statements you wrote here, after the execution of this statement is completed, then the final statement destructor executed will come in the output screen. Okay, so this is one simple example to demonstrate how to use destructors to deallocate the memory which was allocated, right? So when is the destructor called? When actually it is called, we are saying that it is at the end only. We are saying it is done at the end only, but it is done at some situations. Let us see what are those situations. Okay, a destructor function is called automatically when the object goes out of scope. A destructor function is called automatically when the object goes out of scope, but that we cannot feel it. We cannot see that difference. You can observe it whether it is working or not using this. You write a program, you create an object T, then do so many printf statements and write return 0 and close it. Then you will see constructor executed and all these printf statements and then destructor executed at the end. That way you can observe the use of destructors, right? But there are some certain cases where the destructor function is called. There are certain situations where this destructor function is called. What is that situation? Destructor is called when the function ends, when the program ends. Okay, when the block containing local variable ends. Okay, when a delete operation is called. When a function ends, destructor is called. When a program ends, the destructor is called. Okay, when a block containing local variable ends, again the destructor is called. Okay, so these are different situations, but again it does not much impact our programming, because the agenda of creating a variable and no, using printing those values and then deleting those values, you cannot see any difference there, right? So these are different situations where a destructor can be called. When a function ends, it means in that function you might have used a constructor. When that is ending, destructor will be called. When the program is ending, destructor will be called. When the local variables are ending, destructor will be called. Okay, we will see demonstrations for all of them in the implementation phase, how and when a destructor can be called. So these are different situations where a destructor function is executed. How do I call destructors explicitly? How do we call the destructors explicitly? What we try to do here. See, I am saying here, see, we are writing it like this. Manually, we are writing it here. Manually, you are writing negation of the tilde operator of class name, and you are writing some set of statements here. Sorry, not this. Yeah. So you are writing negation symbol with test, negation of test, open close bracket, round bracket, flower brackets, then writing some set of statements. This is manually, explicitly you are giving it. Manually you are writing the logic to destroy the memory allocated for that object. But there is other way, there is another way, even if when you don't create, a constructor, okay, even if you don't allocate memory for an object using constructor, still you can delete that memory using destructor. How? That object name s1 dot tilde operator, the class name student. You can write it like this: s1 dot tilde operator, the class name, round bracket, semicolon. When you write this way, whatever memory was allocated for that object s1, that was not allocated using constructors. Okay, whatever memory was allocated for this object s1, right, without the constructor's help also can be destroyed, can be deleted, writing like this manually. How to write it? Write the object name dot operator, the tilde and the class name like this. What it will do? Whatever memory was allocated for this object s1 will be deleted. So this memory allocated for this object s1 was not through the constructors. It was not done through the constructors. In that case, no, we use this statement to delete it. Okay. When do you need to write user defined? In what cases? In what cases you have to use this, right? So if you do not write our own destructor in class, compiler creates a default destructor. We already know that. Even if you don't write a default constructor, compiler creates one automatically. In the same way, even if you don't write a destructor, compiler will automatically create a destructor. Okay, the default destructor works fine unless we have dynamically allocated memory. The point here is to say that if you are allocating memory to an object using constructor, only then you can apply the concept of destructors. Only those memories will be erased for which memory was allocated using the constructors. But if memory was allocated using some dynamic memory allocation functions, destructor will not work. Okay, next, when a class contains a pointer to the memory allocated in the class, when a class contains a pointer, we should write a destructor to release memory before the class instant is destroyed. So if a class contains a pointer variable, that variable has to be destroyed first before you destroy the class. Before you destroy the class object, this pointer variable should be destroyed first. Why? It was allocated, memory was allocated for that pointer using calloc or malloc or new. Some dynamic memory allocation functions was used there, right? So this is about destructors. If you summarize what we have seen in destructors, destructors are special functions which are invoked automatically whenever an object is going to be destroyed. We can define that inside the class or outside the class as well, right? So there are some characteristics we have to, the name of the destructor will be the class name, but preceded with a tilde symbol. Okay, it is not possible to define more than one destructor. You cannot have more than one destructor, right? The destructor is the only way to delete the memory allocated using the constructor. You cannot overload a destructor like we are doing constructor overloading. Okay, and destructor neither requires any argument nor returns any value. So these are few important points about the destructors. And then we have seen a dummy example to understand how destructor is executed, right? Whenever an object is created, that constructor is executed, then the remaining set of instructions are executed. At the end, while the compiler closes the program, when the program is about to end, the default constructor, the destructor is executed automatically. With this, the memory, whatever memory was allocated, will be erased. And in what cases the destructor is called? When the function ends, when the program ends, right? When the block containing local variable ends, and when a delete operation is called. We will see different programs, implementation for all these cases, how and where destructor can be used. For that, we have to write a program with a constructor and a destructor. So we will see that. So how do you call manually? How do you manually call a destructor? Using the object name dot the tilde operator, the class name. You can write it like this. What it will do, what this statement will do, manually, explicitly, we are deleting the memory allocated for the object S1. But the memory allocation was happened not by the constructor but some other means. That I want to delete. You can even write it like this to delete the memory allocated for a object without the constructors also, right? So this is the concept of destructors in C++. When you write a program with constructors, like when you allocate memory using the DMA techniques, malloc or calloc or new, then definitely you have to use either free or delete functions. In the same way, when you are using constructor function to allocate memory to an object or to initialize values to the object data members, then you by default you have to use a destructor also to deallocate the memory which was allocated it, right? So this is the whole story about destructors.